We have more than 100 registrations, but most of the people want to watch later on YouTube and send their comments and questions. So they got used to do that.
I fully understand also because there are people spread all over the world eventually, so different time and
yeah, 39 countries from this 100. This 100 registration comes from 39 different countries around the world. So good afternoon. We are still waiting for more people to join the session. We will start in a couple of minutes. Well, let's start. Good morning. Good morning, good afternoon, and good evening, depending on where you are. It's my distinct honor and privilege to introduce a truly remarkable and esteemed researcher in the field of marine biology and ecology, Professor Roberto Danovaro. As a full professor at the Polytechnic University of Marche, Professor Danovaro has dedicated his career to study the preservation of marine ecosystems. His leadership roles include serving as the president of the Stazione Zoologica Anton Dohrn in Naples and past presidencies of the Italian Society of Ecology, the Italian Society of Limnology and Oceanography, and the European Federation of Scientific Societies. Roberto's influence extends globally and couldn't be underestimated. Through his membership in several prestigious international panels, including IUCN, UNEP, GPO, as well as the EU Academy of Science. He has successfully led numerous EU projects focused on marine biodiversity and ecosystem restoration. His groundbreaking work on deep sea ecosystem and the impact of climate change has earned him numerous accolades, including the prize BMC Biology, the award of the French Society of Oceanography, and the annual award for protection of the environment. Roberto is also recognized by Expertscape as the top world scientist in the category of ocean and seas for the decade 2010-2020. His contributions to science a profound and impressive portfolio of approximately 550 papers, 10 books, and over 39,000 citations. This is a wonderful, short bio of Roberto Danovaro. So please join me in welcoming the distinguished Professor Danovaro. The floor is yours.
Thank you so much. I'm honored to be here, and I would like to thank you for the presentation and especially for this invitation that offers me the possibility to share with you and with all colleagues some thoughts and some experiences we acquired in the field of restoration. So I'll go immediately to share with you the slides and hopefully start immediately if the presentation is visible to all of you. I'd like—
Yes, please. Sorry to interrupt you, Roberto. Can you change? Can you Scambi Schermo? Yes. So
we made right. We made an attempt.
Yeah, on the top, if you say Scambio Schermo.
Yeah, we did it just.
Because what I'm seeing is your desktop, not the presentation in presentation mode.
Right. Should be
perfect. Now, if you could start again.
I'm back. I hope.
Yeah, no problem. Yeah, it happened. Yeah.
Oh, it happened. Let me share again the screen and see whether we can manage to the view that provides. So how it is now?
It's again. You have to change again. Yeah.
Right.
Yeah. Scambio Schermo.
All right. So
if you go down there, yeah.
This way, but this should be—
No, if you go down there, no. Now the presentation is not in presentation mode. If you present again.
Yeah, here. And then.
And now it's Cambio Schermo. Yes. Yes, correct. Now it's perfect.
Okay, thank you very much. My apologies for this. We made an attempt before, everything worked well, and now we are not the same way. So thank you for inviting me and for offering the opportunity to discuss with you the challenge of restoring marine ecosystems, not just in European seas, but as a matter of fact, this is a topic that is, of course, of global interest. First of all, we should, I think, understand the dimension of the problem we are facing. According to the recent estimates, marine habitats face an unprecedented level of multiple impacts related either to direct physical disturbance plus the impact of global change. I would say that we are all aware about these problems, but what is very striking is the dimension, the extension of the damage. We are physically destroying, especially through bottom contact fisheries, but not only that, almost 5 million square kilometers a year that represent 1.3 of the global surface of the ocean. And this is a huge dimension. In many, many cases, these impacts are repeated over time, and they generate an overall destruction, simplification of the habitats. Just to make an example, a few years ago, we published a paper on PNAS demonstrating that bottom trawling along the slopes of the Mediterranean Sea were able to create a certain kind of desertification of the habitat that was resembling the 500-meter depth, a kind of habitat at abyssal depths in terms of biodiversity and more in terms of biomass. Not to mention the expanding problem of the deep sea mining, which is targeting polymetallic rich nodules, but also seamounts and other areas. But as far as the Clipperton zone is concerned, at about 5,000-meter depth, the dimensions are extremely large, and we are talking about a dimension that may be of a few European countries pulled together. So it is clear that we are facing increasing problems. Second, are all habitat types subjected to the same impacts? Of course not, but we don't know very much about that. If I will ask you, do you know the extension of the damage in your habitat in Brazil for the coral reefs of the water corals, or in the North Sea for the seagrasses, in the Mediterranean for the macroalgal forest, or whatever, or vice versa? Of course, we have a clear idea. But we tried to make a guess, for instance, for Italian waters, and it looks like for the macroalgal forest, the brown forest, like kelp, but not kelp, in the Mediterranean, the dimension, the extent of the loss is in the order of more than 80% when compared to a few decades ago. And a scenario which is negative, although not so much negative, is also for seagrasses, and especially for the endemic Posidonia oceanica in the Mediterranean region, that decreased by 25%. Now we know that we have a huge work to do, and that also the cost for this restoration might be very high. This brings us to another question. So, do we really need marine ecosystem restoration? Are there other alternatives? I would say even less expensive, more affordable, easier alternative. And the answer is no. We do need. There are no alternatives. We need marine ecosystem restoration according to this kind of concentric loop of problems that we should, carry on simultaneously and coherently. In general, we know that we have to go to the zero pollution approach. And this is a well-known target also of the STAR mission at European level, along with the need of contrasting climate change. So this is the setting the scenario, reducing the pollution. Of course, this has to go in parallel with the protection of habitats to stop biodiversity loss, for instance, to stop the bottom contact fisheries, to stop the habitat degradation, which is not just due to pollution, but also to the direct impacts, physical impacts. But we also know that if we don't kick off, we don't start the restoration for most of these habitats, there is not a chance to recover for decades or more than that, maybe for centuries, depending on the habitat. Certainly for decades for the seagrasses, possibly centuries for the deep sea and the polymetallic nodules. This means that since we have not the time to wait for, we need to provide active intervention of restoration. And this brings us to another question. Since we now understand that we need to restore is, well, but if you intervene and you provide an active restoration intervention, what's the chance to have a successful restoration? What's the chance not to fail, to make a good investment, so that the effort and the money we invest will return in a positive output? This is an important target. We need to focus carefully on that. And I think this is a priority that we've started acquiring in 2015, when we started with the project MERCES. So mapping the extent of habitat damage and putting together the available protocols to demonstrate whether the restoration efforts can effectively contribute to restore the habitats, to maintain healthy habitats for a long time, to recover biodiversity, and to recover, of course, ecosystem services, so that we could really achieve the targets set up by the UN Decade of Ecosystem Restoration. As we all know, that the decade 2021-2030 has been dedicated by United Nations to ecosystem restoration. Okay, defining success is a clear, target. If we want to measure the success, we need first to define. So defining success means an intervention that enables the recovery of the biodiversity and of the ecosystem functions of a previously degraded ecosystem to values that are similar to reference areas. So in terms of biodiversity, whatever. This means that we have to identify the degraded area, yes, but also to identify the reference, the targets we want to achieve after the restoration intervention. So the next step is, well, this could be done, but do we have some case studies of success to show the feasibility of these restoration interventions? And not less important, are there differences and the possibility to have success for the restoration interventions? Well, so far, the restoration interventions have been carried out in 8 habitat types, including seagrasses that I mentioned before, and macroalgal forests as well, but also salt marshes, which are in between, like mangroves, in between terrestrial and marine environments. But we consider, for many reasons, in this perspective also, fully marine habitats, oyster reefs, which showed a tremendous decrease over decades. I was mentioning before about the macroalgal forest, but oyster reefs in certain areas decreased as well by 80% or more. Coral reefs, of course, for which we have a long history of attempt and success, and including also animal forests, gorgonians, and others. Finally, to deep sea ecosystems and the cold water corals you might see also here in some pictures. Now we completed a meta-analysis and various statistical approaches to describe the success over a total of 916 cases documented of restoration attempts. And the final output is very, very positive, because we discovered that although with some differences in between some habitats and others, we on average have an expectation of success ranging from 70 to 80, in some cases 90%. It means that if you put under back, on average, 70–80% of what you put back in a damaged habitat will survive and will recolonize and will recreate a pristine ecosystem along with the biodiversity it contains. We also explore 2 other, issues on that, which are always coming from the experience we made on MERCES. And the first one is what the risk for a complete failure. So think about restoring and making an attempt to restore seagrasses or deepwater corals. What's the chance we have, the probability we have to lose everything for whatever episodic events, wrong habitat type, wrong methodology, many reasons? Well, we have a very low percentage. For most of the habitats we explore, the potential failure is always less than 5%. And only in a couple of habitat types, including seagrasses and salt marshes, we have a potential failure related to the complex dynamics of the shores and the tremendous risk we have of further human impacts on the shores, which is above, the risk of failure is above 10%, and in one case above the 20%. But for the rest, the risk of failure is very, very low. So we'll say also statistically negligible in some way for the scientists. Of course, this is not completely negligible, but certainly affordable also from the point of view of the interest of the private sector to enter in the future business of ecosystem restoration. Another interesting point is described in this picture you see over there, which is a map of the global cumulative impacts all over the world. This is derived by a fantastic work carried out by Alpen and colleagues and published first in Nature and second, if I remember well, on Nature Communications. And we overlapped, spatially overlapped the interventions with the cumulative impact gradient. Why we did that? Because looking to the experience in terrestrial ecosystems, there was one keyword for all of them. Terrestrial ecosystem restoration states, first, remove the impact, then restore. Since in our experience, very few cases for marine ecosystem restoration, the damage was removed. I mean, the contamination or whatever, the environmental problems were removed before the intervention. We wanted to assess if this can provide a negative return on the intervention. And the result is quite amazing, because we discovered that restoration interventions are equally, successful in impacted and in non-impacted ecosystems. And this calls for another very important conclusion to us, is that we can start restoration immediately, because even if you start restoration in a contaminated or impacted habitat, you have a high probability, very high probability of success without removing previously the impacts. So means that we do not have to wait. We can start immediately. And this is an important, of course, success. All these data were acquired through the project MERCES, Marine Ecosystem Restoration in Changing European Seas, which was an H2020 funded project starting in 2016, but with a pre-start in 2015 and ending in 2020. The ambition at the beginning of the project, as I anticipated before, were, do we have solutions for restoring biodiversity, for restoring habitat and reintroducing biodiversity? And if we have some protocols have been tested in different biogeographic regions. So the attempts we carried out on some seagrasses in the Mediterranean using the same protocols can work also in the North Sea or in the Atlantic region. Then the second is, what's the degree of effectiveness, either in terms of recovery of biodiversity, but also from a socioeconomic perspective in a cost-benefit analysis. And then the third measure ambition was, we do need legal frameworks, policy tools, and governance frameworks to sustain, promote, expand, make even more successful these attempts. Let me tell you a side story about the MERCES project. We participated to a call that was oriented to terrestrial ecosystems, because we have a much wider experience in terrestrial ecosystems. And I think MERCES was the only marine project proposed within the framework of 50 other projects focusing on terrestrial ecosystem or freshwater habitats. And we got the financial, we ranked first, by the way, and we got the financial support by the European Union because of the innovation of the orienting, of course, this kind of tools also to the marine environments, and for the first time also to tackle with the problems of the deep sea ecosystems, which is not a minor one, because most of the intensive trawling is carried out beneath 200-meter depth, so in deep sea habitats, by the way. So for that reason, we created a network, not just to explore the restoration in several coastal areas, but for the first time, a few years ago, we started also exploring in a few sites the restoration in hydrothermal vent area, in deep sea coral gardens, over the Palinuro seamount in the Mediterranean, over deep sea fjords or abyssal plains. And that pilot studies were very, very interesting because we're allowing for the first time to apply some principles that were coming from the shallow water experience for tropical corals or for the use of artificial substrate to promote recruitment. And in other cases, we were also using, so to say, the imagination to expand the possibility to recover life for the restoration. For instance, look at the decommissioning of oil platforms. They are fully colonized by a number of organisms that can be used instead of killed by the decommissioning, but can be used, reintroduced in the environment, recolonized. Some structures were monitored over time. So we clearly understood, and this was confirmed by the previous analysis, but also the restoration of deep sea habitats can be very, very successful, but requires, of course, an important technological engagement. We need ROVs, we need, of course, large ships and so forth. But all attempts were successful so far, and we're bringing new life, offering new opportunities, restoring biodiversity, increasing the local biodiversity, and remained over time with the minimal support and maintenance. On the basis of these previous results, we understood a few things. That ecological restoration can be carried out without expensive technologies only in very shallow waters and in limited areas. We can carry on without much technologies, marine ecosystem restoration for salt marshes, maybe for macroalgal forest, using scuba diving, possibly for some animal forests, or for seagrasses. But certainly we can cover maybe 95% of the damaged habitats all over the world. To carry on large scale important restoration interventions, we need to develop cost-effective underwater technologies. So we need to develop or to adapt existing technologies for the scope of restoring deep sea ecosystems, but also mesophotic habitats. And we have to find a tool to optimize the restoration success in order to increase the efficiency, to decrease the cost, and increase the overall cost-benefit analysis results. One of the big issues we were unable to tackle with the first project, MERCES, is understanding that, of course, restoration works, but in terms of spatial extension, in terms of dimensional restoration, has nothing to do with the ability of terrestrial restoration to restore huge areas. Think about the project of the Great Green Wall crossing the entire Africa to stop the expansion of the Sahara Desert along thousands and thousands of kilometers. This is certainly not the case for the marine environments, although there are attempts to restore mangroves over millions of hectares, and the same for macroalgae. But the good news are that according to our results, the dimension, the scale of the restoration is not the guarantee of success. So any intervention, small, large, or extra large, has the same probability of success. So we certainly can even think at the local program of small-scale restoration interventions that together can be connected and expand the overall significance of the restoration intervention. Clearly, however, what we have in mind is that we need an important technological effort. And in my opinion, this was the meaning of the paper we published in Science. No one alone can do it. No one alone, not a single country, not even the European Union alone probably can do the work without a cooperation and intergovernmental cooperation and coordination of the efforts, exchange of knowledge, sharing of infrastructures and technologies. Since this has been done, for instance, for the aerospace corporation, for the whatever, why not thinking at a similar strategy of global cooperation for developing the protection, restoration, and sustainable development of the global ocean? All in all, the take-home messages of the MERCES were very important to us because demonstrated that the current knowledge is sufficient to have a very successful restoration intervention is important. We demonstrated that through many cases, and we developed also conceptual frameworks demonstrating that restoration can work for long time scales, and that the next challenge was not that demonstrated that it works, but to expand the scale of ecosystem restoration and understanding how to lower the cost by increasing the effectiveness of the ecosystem restoration. In addition to that, when you do a restoration intervention, you often need to create a kind of buffer area that allows the restoration intervention to be protected from further impacts. In other ways, if you repair a deep water coral that has been damaged by deep water trawling, after the restoration intervention, if you do not protect from fisheries the area, you have a high probability that everything will be removed. So when you do that, by protecting the surrounding areas, you also increase the ability of the corals not to be maintained over time, but to be expanded, to expand and to colonize far larger areas by increasing, therefore, the extension of the value and the scale of restoration intervention. And so with a very limited cost, that is the one of protection, profiting of a very important expansion of that. So this means that in the future, conservation, marine protected areas, as well as, for instance, other cost-effective area-based conservation measures, OECD, or any intervention or buffer area surrounding the restoration interventions, all of these activities might contribute from one side to promote to expand the restoration intervention, from the other side to promote the natural resilience. So what is called also the passive restoration, so less the system to recover. It is a bit slower, we know, but for some systems might work, especially in shallow waters. And altogether, we might certainly achieve better targets. We also understood that there are several lessons that were learned for terrestrial ecosystems and from coastal ecosystems, but terrestrial and marine ecosystem restoration can follow also different principles. Some key concepts might be in common, others are not. We also know that there are some systems that are slow responding and so need some extra interventions. All in all, however, the conclusions we got from the first project, MERCES, are very, very intriguing and encouraging, I would say, because they say that there is a robust evidence of highly successful marine ecosystem restoration. So you do that, it works. You really start from a degraded mat and you recover the seagrass system. You start from some bare, rocky sediments. You return to algal forest. You start from rubbles of coral, deep water corals, and you return to a very rich deep coral reef. There is also in parallel evidence of a very low risk of complete failure, in most cases, less than 5%. We have also evidence that we can do multiple interventions at small spatial scale, so involving the local communities with low budgets, and have them successful as for the large-scale interventions. And then every single drop together can make an ocean. So we can scale up the dimension of interventions by summing up all small-scale interventions. Because we don't need necessarily large-scale interventions to have a success. And last but not least, I think it's very important, you can do that now. You don't have to wait. There is no need first to intervene by removing the past, decontaminating, whatever, because in most cases you have an acute, degradation, but then selecting the right, colonizers, the right species, whatever, you might have a very highly successful restoration, even in degraded habitats. And this was the case coming as a kind of, clear evidence of results in all studies we investigated. And I have also personal experience in that. We restored Posidonia oceanica in one of the still most polluted bays in the Mediterranean Sea, in the Bay of Bagnoli, close to Naples, where we still have contamination of hydrocarbons, heavy metals. It is a site of national interest for the problem of the contamination, of course, and we were very successful also in that case. So very encouraging. That was also posing the premise for the future steps. So we understood through the MERCES project that we have to move forward. We have to improve protocols for further increase the success of restoration intervention. And we need to do that for all the degraded habitats. We have limited to no experience on the polymetallic nodules. There is one interesting project going on, I think, as a JP project coordinated by IFREMER on the restoration of impacted polymetallic nodules. We need to do more for hydrothermal vents. We don't know almost anything about the restoration of coal seeps impacted by activities of methane extraction. So we have protocols so far only for a minor portion of the deep sea habitats. For instance, we are running right now in the project I will present shortly, the restoration of pen fields, sponge fields in the deep sea, and so on. So there is a huge number of habitats, but so far we have experienced restoration only in some few emblematic, paradigmatic cases, coral reefs, seagrasses, and so forth. The second issue is that we need to decrease the cost for the restoration intervention to make that not only more accessible to the current financial support, but also more convenient in terms of return of investments, because this is the only way to engage the private sector. And I think, but it's my personal view, of course, that the work we are doing as scientists is important to set up the protocols, to identify the best solutions, but the future of marine ecosystem restoration is the future of the private sector. Is a future in which, no matter if for restoring, historically degraded habitats, thanks to financial supports to the investments of the World Bank, or if the money comes from private companies to compensate the impacts, but the future of the marine ecosystem restoration relies upon the private sector. However, on the basis of these results, we wanted to tackle another important challenge that the European Union brightly identified, the need of expanding the restoration the knowledge on the restoration, the feasibility of restoration of deep sea habitats, to rebuild the European seas, the biodiversity in habitats. This was the topic of another call we participated to, and we got it because the Redress project was approved and financially supported, and we had a kickoff meeting a couple of months ago. So now in early 2024, the aim of the Redress project is to demonstrate the feasibility, sustainability, and value of deep sea ecosystem restoration in order to provide the solutions that are so important also for the Antarctic and Arctic Lighthouse, and to contribute to the European Green Deal and general terms to the objective of this Sustainable Development Goals, especially for the SDG 14, but also 12, 6, and so forth. The actions and the targets of the redress projects are easy to follow and are here described. First, we need to map the degraded marine habitats, not only to have an idea of the dimension. I started this presentation saying how large is the dimension of the problem, but also because we need to develop a roadmap for the prioritization of the areas to be restored. Of course, since we are talking about huge spatial scales, we are unable to restore all of them, and unable to do that either for economic reasons, of course, but also because interventions require time. So we have to start from somewhere. And the way to start is prioritizing the intervention. So define the areas for which we do expect to have the most important returns in terms of ecosystem services, in terms of biodiversity. So an example is identifying the potential of deep sea refugia to be restored, also to provide an opportunity to the species and deep sea species to resist more to the impacts of climate change. Of course, these interventions have a target to reverse the biodiversity decline, but not only that, because by reversing the biodiversity decline, they also offer new opportunities to increase the production of the oceans, to recreate nursery areas for the important commercial fish species and so forth. This offers also an opportunity to increase the returns in terms of fisheries or other marine activities and industrial activities. Of course, to do that, we need to develop technological tools and nature-based approaches for two reasons. Technological tools, of course, because we are operating in the deep sea, and nature-based solutions because restoration is a nature-based solution. Sometimes can be based also on the use of artificial reefs, for instance, but certainly requires a maintenance over time. So we also demonstrated in the past experience that it's not just fixing a car that was broken. Restoring means starting a process. And when you start the process, you have also to take care of it, to be sure that the restoration intervention will work for a while. So this is also focused on decreasing the cost, involving the SMEs. In the MERCES project, for instance, only at the European level, we identify a kind of a business club of 350 industries that were, clearly ready to move into the sector of marine ecosystem restoration. This is just an idea of the project structure. Identify the priority area, developing innovative approach or restoration of all vulnerable habitats, the technological problem, but also the socioeconomic analysis, the evaluation, the benefits, the financial support, and last but not least, definitely the governance structure, because without governance, we will see at the end of this talk, we are not moving too far. of course, altogether, management and dissemination as always. In this last project address, we involved 26 partners from 16 countries, from Iceland to Israel, covering a broad spectrum of deep sea habitats and biogeographic regions, and working together in synergies, cooperating, moving, and sharing technologies and opportunities. This is an example of the important selection of areas where different habitat types will be restored, from cold water corals and the so-called Delophilia pertusa. We also are ready, and we will start the use of corals colonizing oil and gas infrastructures to be used for the restoration, salt bottom communities, madrepora reefs, black corals, coral gardens, and so forth. The technological, the sophisticated technological portfolio was also another added value, in my opinion, of the project. So here, restoration is done by a large pool of colleagues from biologists, ecologists, geologists, but engineers, of course, socioeconomists, lawyers, and whatever. We all have to work together, but in particular, the technological value of the intervention is very, very important, because in this way, it's not just a matter of access to the deep sea, but also to run restoration routinely on large scales, which might, make the difference in the future. And this is also coming from the need of pulling together three main types of enablers that we need for restoration, not only of deep sea ecosystems, in general of all ecosystems, which are policy regulator enables, laws, and whatever. Economic labors, we need money, investments, financial support. But the third one is certainly a technological one. We need technologies to lower the cost and to increase the efficiency. So, last slide to conclude is that we are facing a very promising, but yet still very challenging era of the ocean, management, I would say, even discovery of new opportunities, where the most theoretical backgrounds of ecology are matching the targets of the technologies, applied ecology, socioeconomical evaluation, but also local heritage, culture, defense of the diversity of the local population, the traditions, and valuing of the marine ecosystems. And for this reason, as you well know, there was an important proposal, the Natural Restoration Law at European level, for a regulation of the activities and conditions to carry on restorations in terrestrial, aquatic, and marine ecosystems. We were all looking with a huge hope to this law, which has been currently stopped by a very, very strange and controversial debate among different, opinions at the European level, which are made even more problematic by the future elections. But I still hope that this crucial, important law will be approved and applied and can be useful to expand something similar in all regions of the world, because we need a law to show that nature is part of us, is not something that decreases the possibility of developing a good economy, but is a new opportunity to develop a new economy, which is pulling together positive effects of defending the environment and providing new business opportunities. This is what we will do with the REDRESS project, and this is what we hope we can do together with our colleagues all over the world. So thank you very much for your attention.
Oh, hello, Roberto. So wonderful presentation. Thank you so much. So much information to unpack, you know, in the following minutes. I have a few questions myself, but I go first with a question from Claudia Almeida. Thanks for a great talk, Professor Danovaro. It is a very optimistic and uplifting presentation. I completely agree, which is very important to counter the environmental doomsday narratives. My question is, it seems that we can act now and get very good results. The question is, what are the barriers that are preventing governments to act in a large scale? Also, in your opinion, why the private sector does not invest in restoration if there is such a big market?
Yeah, thanks so much for this question that allows me to clarify a couple of points. First one is easy. The most important barrier is money. Money, because we need to invest in that, of course. Now, the problem is who pays? Of course, I think that since ecosystem restoration is returning back to the people, the natural capital, I think as something ethical should be promoted, started by public investments. So it's something that belongs to all of us. Of course, if you identify a private company causing a damage, they have to pay for the restoration. So far, we are investing in restoration, but technically, this is not a restoration truly sense. It's just named compensation because they have to compensate impacts and not to look to the past. The past is gone, and so nobody cares about that. So that's why we have to look at that. From this point of view, what I think is an important enabler, a law that clarifies that according to the rules and an environmental impact assessment, you can do whatever, but at the condition that you don't cause any damage to the environment, any significant negative damage. If you cause a minimal damage, you have to restore. If you cause a very significant damage, you don't do that until you don't find a best solution. The future of the private companies is there. They are now working for compensating. I hope they will be working in the future also for restoring. And I know that there is a very broad and an important possibility also from the World Bank that is like with 10 years ago, we were starting with the green bonds. Now we are starting with the blue bonds, and the blue bonds will be dedicated to not just conservation, but first of all, restoration, because this creates an opportunity to involve an economy, to provide new professional skills and opportunities for employment for the people. So I think tools like the World Bank or the countries are those that can promote this process.
Sorry, thank you for your answer. We have a question from YouTube. I mean, we discussed already before opening the session that how can you manage, I mean, ecological restoration, marine restoration when you have sewage systems that do not work, for example? These questions come from Brazil.
So when you have what?
When you have sewage systems, I mean, waste management systems that simply they do not work.
Yes, that's could be an apparent, paradox, but I tell you that it works. The problem is if the sewage systems are those causing the decline, I understand you have first to manage with that. But in many cases, the problem is not the sewage system, which provides pollution, of course, but also a lot of food, say so. But another source of impact that causes the decline of the habitat. Therefore, in that case, restoring may be even the solution to decrease the impact of pollution to the sewage. So nature is the one, managing the sewage, reducing the organic loads, and increasing also the vulnerability and the quality of the waters. So can be the solution instead of being, the impacted, target.
Sorry, as you know, I'm coordinating the BlueMissionAA project. It's focused on restoration, and how can your solutions be replicated, scale up? So the Mission Ocean and Waters has very ambitious targets by 2030. So we are just starting, Redress is just starting, MERCES just ended. You know, there's a few solutions available, but still there are hundreds, if not thousands of kilometers to be recovered. How can we do that in such a small period of time?
Yeah, yes, this is a good question indeed, Giuseppe, because we know that the restoration is a process. It's not that something magic, with a stick, magic stick. Something we need to do to carry on. Sometimes takes years for the intervention and maybe 10 years to achieve the full restoration. But we need to start. We can start at the local level. Think if every single marina, every single port, every single municipality at sea starts its own little project involving the local communities that take care of. They are proud of it. They show to the tourists the importance of the activities they are doing. They go, monitoring together, snorkeling together, involving the volunteers. I think this has a double advantage. You can do that with limited budgets, expanding, using the restoration as a tool for the education of the people, even an attraction for tourists, for a more sustainable blue tourism, for instance. So we need to develop an approach in that way until the governments eventually soon will make larger investments in that. Italy, a couple of years ago, invested something like maybe 300 million euros to restore oyster reefs and seagrasses, which is quite a relevant budget. Insufficient to do everything, but a good start for. You're muted.
Sorry. At the same time, you said you need technology to ramp up the ecological restoration. No? How can you mix grassroots movements with a very limited budget and a very limited geographical footprint to 30% of European ocean and waters?
Yeah, correct. So there is habitat and habitat, of course. If you're looking to the restoration of mangroves, you don't need much technology. You just need seeds, like a plant. You plant the seed on the shore, you protect, you manage. But if you go to the restoration of macroalgal forest and for instance, of seagrasses, in many cases, you can involve local people, scuba divers, fishermen, so you don't need much technologies. But certainly, which is the target of the Redress project, you need important technologies if you move at sea. Even though we are now running another approach, which is very, very easy. The approach is named badminton, which is the game of, which means in many cases, one of the substantive impacts are that even local fishermen through the nets can catch the gorgonian, can catch the posidonia, can even catch the deepwater coral. Now, the new strategy is, instead of throwing away these corals, the material, you put back and stick on the base, and you throw back at sea, and they survive. So this very simple, mechanism is providing the supports and the stick for the attachment of the corals to the fishermen, and of course, instructing the fishermen in that sense could allow them to do a natural restoration, expanding the colonies, returning immediately at sea, or incubating for a while in the aquaria. But this practically results in a zero impact and the possibility to spread further the restoration intervention. And this has no cost. Of course, in some cases it works. In others, we need more important technologies. But some, activities can be done.
So bring on board the young people is very important because they all come up with very great ideas. I remember last year we had a meeting, with students, 400 students in a high school in Milano. It was fantastic. So we discussed together their ideas on how to solve the problems with kelp forest. I was surprised because they all knew about the problems of the kelp forest and they identified the urchin. So they come up with the idea, let's promote eating urchin, so at least we will reduce the stressors. So this kind of bring on board and have these small ideas could be really ramp up restoration.
Yes, or just to bring the sea urchins and move the sea urchins where they are not anymore present, because these are important also for the equilibrium. There are some places where there are too many and others where they disappeared. So we can also, bring that. But you mentioned something important. The young generation is the future also for restoration. We started a couple of courses here at the Polytechnic University of Marche in Italy within the frame of the International Master, European Master in Marine Biological Resources. And I have a huge return from students from 20 countries, from Canada to India, from France to Spain, and whatever. They are all of them keen to start this new profession and to acquire the knowledge to be the restorers of the oceans of the future.
Good. Well, I have two more questions, and I hope somebody will keep asking questions, but I still have, in your presentation, in relation to deep sea habitats, you said that most deep sea systems apparently do not recover without active restoration efforts. So must be active project with lots of funding to make it happen. And you said the trawling industry in some cases are responsible for at least some of these problems. Do you think it will be possible to link, if you to get rid of the trawling industry at all, or link them to pay the damage they do? What do you think would be a solution, a compromising solution?
This is a very tricky question. It's very, very difficult.
I know, that's
But
why.
I'll try to respond. I'll not escape to this question. So we know that trawling is probably the largest problem we have in the ocean. It's not plastic, it's not microplastic, it's habitat destruction. Is the first. Then the solution could be stop trawling, but we have no way. There are lobbyists pushing. There is a lot of economic interest. Think about the Brexit and the discussion they had for fisheries in an areas or another one. But we could try to ameliorate, mitigate impacts. For instance, setting the maximum depth of trawling that now has no rules in the Mediterranean is no trawling beneath 1,000-meter depth. If we start saying no trawling beneath 600-meter depth, that would be a fantastic support, because a lot of species can reproduce a 700, 800, 1,000-meter and refurnish, restocking shallow water ecosystem. If we throw down everywhere, of course, we don't give a chance to a system to be ready for expanding and renewing the biomass. This is maybe is not the solution, but would be a step forward.
Good, thank you. And we have a question for Eduardo Carquejeiro. The future relies on the private sector, you said. Aren't we taking the risk that, for instance, mining companies enter the process as a compensation? In one side, we open the deep sea for exploration, and on the other, we ask them to compensate. Or the fishing sector, we just discussed that now, for instance, trawling allowed if companies restore the seafloor. Maybe these examples are too radical, but what contrapositions do you give to a company to support the restoration? What private sectors are you thinking of?
Thank you. This is a very important question. And I tell you that we published a paper in 2014 with Barbier and others on Nature, where we calculated the costs for restoration of deep sea polymetallic nodules. And the cost for restoration are 4 times as much of the gain of selling minerals. So repairing is always more expensive than damaging if this is the target, just collecting. But this could push the companies tomorrow and say, instead of using a bulldozer to get polymetallic nodules, why are not developing a system to pick up, without impact, one by one, yes, you will collect less, a lower number of nodules, but without an impact. It's like going in a wood, in a forest for mushrooms with a bulldozer instead of picking up the mushrooms, as they say. I mean, why not developing, approaches which are less impacting than those we use? Of course, it's more convenient using a bulldozer if you don't pay for the destruction. But if you pay, the companies will be pushed to do that in another ways. And so I think I see a kind of educational approach. And the same will be for fisheries. But fisheries are something that has a long tradition, and it's like saying you are, destroying the culture. The culture is an heritage. My grandfather was fishing, so it's like something in which the people put something that is part of the history of the local history. So in that perspective, it's much more difficult to to ask for paying for the damage. So we need to find other solutions.
Oh, yes. I mean, we have still 3 questions. I know after the hours, I hope you have time. I mean, it was a very interesting presentation. And this is from Farah Nibs. This was a wonderful presentation. I do have a question. How do you see the role of small island states in the preservation of their marine ecosystems, given their limited financial capital and low research output in this area?
Thanks. This is a fantastic question because we know that small islands are probably the key of success for the protection of the oceans. As a matter of fact, small islands, even the most isolated, they might have, the exclusive economic zone of a radius of 200 miles. So they have huge extension of the marine territories they can manage. And I think that exactly because they have, in many cases, not a tremendous economic power, they have to preserve their natural capital because this is the only guarantee they have to be sustainable over time and not to become poor. And we know that important mineral companies are acquiring the rights of exploitation of the marine resources in so small islands, and we need to develop, thanks to the United Nations and to the Convention for Small Islands Sustainable Development, tools to support the small islands against the aggressive, economy of the multinational and international companies.
Yes, I completely agree. I mean, we have now a comment, not a question, but a comment, but very interesting comment from Ivan Conesal Colea. Money exists. Harmful public subsidies that make bottom trawling profitable have to be diverted to restoration and stewardship practices within the ecosystem and functioning boundaries. No public subsidies, no trawling. Any comments on this comment?
Fully agree, especially on the subsidies. It is much easier to get a popular consensus giving money for subsidies than to get a consensus by restoring the habitats. Takes time, is not visible. Money are visible. So the governments, the politicians often prefer to pay the fishermen than to give them back the fish through pristine habitats, to preserving nature and restoring the damaged habitats. This is a wrong side of the politics we should turn up and contrast.
Yes, exactly. Let's go in line with the continuation of this comment by Ivan. We need to shift from economy functional on return of investment on short term, just a couple of years, versus economy at place with nature, processes, time scales, and species. So now, a final question. I mean, I hope it will be a simple answer, but we never know. I mean, you went through several projects, several habitats. I mean, a lot of solutions, a lot of ideas. Your work is fantastic. But if we would have to start now in Portugal, in Spain, or whatever, in Brazil, in Angola, South Africa, where would you start with the restoration in terms of marine ecosystems? Where can you get the best results in a shortest period of time, to prove to governments and investors that is feasible. We can make money with that.
That's a very nice question. Thank you, sir. I would say that I would exploit the local ecological knowledge. I would go to the old fishermen and to the people living there, say, what has changed over the last decades? What was there and is not there anymore? And I would start from their comments, say, well, was rich of that and now nothing anymore. And I will focus, I will give a priority to that. We need to recover the oceans that our grandfathers, explored and profited before we came. And I think that putting together the scientific knowledge with the local culture, we can really work identifying the priorities, starting from the shores, starting from the systems where the place we bath in and which are close by, because this supports the evidence that we can do something practical, successful, which further promotes future interventions. I hope so, at least.
Oh, it's with this wonderful response, with wonderful message. I thank you all for being here. And thank you, Roberto. Wonderful presentation. Lots of questions, a lot of interaction, a lot of knowledge. Thank you so much. So we will keep in touch, because I'm sure we will receive more questions for you. And I can see by here that people really enjoyed the presentation. Thank you so much, Roberto. And congratulations for both projects.
Thank you very much for the invitation, and see you soon. Bye-bye.
Okay, bye-bye. Bye.